Hi, welcome to the video on implementing logistic regression. By the end of this video, you will be able to implement logistic regression. Now that we have completely understood the logistic regression and its evaluation metrics, let's see how to implement it in this video. Please note that this will be a quick implementation considering the fact that we have covered the concepts of data exploration and feature engineering beforehand. To demonstrate the implementation, let's look at a business problem. Let's say you are a data scientist at a bank and the bank wants you to predict whether the bank customer will churn or not. Or in other words, whether the customer will be able to maintain the minimum required average monthly balance or not. To predict this, we have the following information. Details of the customer such as age, gender, occupation, etc. Details of the customer bank relationship such as customer category, transaction details, etc. Customer account balance details such as monthly average balance of previous months, current balance, etc. Now, on the basis of this information, we have to implement the logistic regression model to predict whether the future customers will churn or not. So let's start by looking at a data dictionary. Now, what is a data dictionary? Well, it is a centralized repository of information about data such as meaning, relationships to other data, origin, usage, and format. Data dictionary. There are multiple variables in the dataset which can be clearly divided into three categories. First is demographic information about customers, which includes customer ID, vintage, age, etc. The next category, that is customer bank relationship, includes customer NW category, branch code, and days since last transaction. The third category, transactional information, includes current balance, previous month-end balance, and many more including churn. Our objective is to model the given data and predict whether the average balance of the customer will fall below the minimum balance in the consecutive month or not. Now let's start by importing the dataset. The name of the dataset is churn_prediction_simple.csv and the same has been given in the helper text below the video. Now the data has been imported successfully. Next step, we will simply drop the missing values as we are only interested in looking at the implementation right now. To do this, we will use data.dropna function. After this, we will use data.info functions to gain some insight about the data types and the number of instances in the dataset. So let's run this cell. We can see in this cell that the dataset is similar to housing prices and there are no missing values. Out of these 21 columns, the column churn is a target variable. You should note that we have already done the minimum required encoding. The original dataset that we will give you for assignment as a part of this module will look fairly different from this one, and you are expected to perform data processing steps on your own. Now let's have a brief look at the target variable churn. We will start by checking the distribution of the target variable in the dataset. For this, we will use the value_counts function and divide it by length of the dataset to obtain the result in fractions, as they are always more insightful than absolute numbers. We can see that classes are roughly in the ratio 80:20, which means the dataset is imbalanced. Now the next step would be to separate the independent and the dependent variables, scale the dataset and split the dataset test set and training set. As we have seen this before, we will quickly run through it. Finally, our data is prepared for the modeling. Now we will move on to the next step of building the logistic regression model. For this, we will begin with importing the logistic regression class from the sklearn.linearModel module. Note that we are importing logistic regression as LR. And then we make an instance of the LR class as a classifier. But the thing you should note that we are assigning a parameter class_weight as balanced. This is an indication for the logistic regression algorithm that it should give emphasis to the classes depending upon the number of observations present in the data. In our case, the target variable is present in the ratio 8:2 for class 0 and class 1. Therefore, the weight assigned to them will be 2:8. We are doing this because we have fewer instances of the positive class. As a result, logistic regression will focus more on classifying the majority class 0. But why? This is because the majority of the error is introduced in the model due to the class 0, and therefore the model will focus on minimizing the error, and therefore it will ignore the minority class 1, incurring less error. By assigning balanced weights, we'll add a multiplier to the minority class 1. Whenever the class 1 instance is misclassified, the error incurred is multiplied, and therefore this increased error cannot be ignored by the model. As a result, the model has to give equal significance to both the classes irrespective of imbalances distribution of class 0 and class 1. This is very helpful in case of imbalanced datasets. Similar to what we did during the implementation of the linear regression, we will use the classifier.fit function and pass the training data to it, which are xtrain and ytrain. Now in case of logistic regression, we have two different ways of predictions that we can make. First one is the prediction of classes for each observation. In this, predictions are made in the form of the class label 0 or 1. The function used for this is classifier.predict, and we pass the x_test into this to predict values. We are storing the result in variable predicted values. The other method is used to predict the probabilities of the observations in the dataset. These values are very important in classification problem. For this, we use the classifier.predict_proba function, and we pass the x_test as the independent variables to be predicted. We are storing the result into a variable called predicted_probabilities. On printing the predicted values, we can clearly see that the output is in the form of discrete values of zeros and 1. On the other hand, when we print the variable predicted probabilities, the output is in the form of a two-dimensional list. The first column represents the probabilities with respect to the class 0, and the second column represents the probabilities with respect to class 1. This can be verified by observing that the first predicted class is 0, and in the probabilities, the first element of the first column is a probability over the value of 0.50. Now that we have the model built and the predictions ready, we will move to the evaluations metrics for the classification model in the next video.